Good afternoon, Namaskar. In this video, we are going to talk about the reflexive, symmetric, and the transitive relations. Here is your presenter, Moise Masa here. So, in this topic, we are going to discuss about the first, what is reflexive, symmetric, and the transitive relations. And in this topic only, video only, we are going to discuss about the how many reflexive and the symmetric relations are there on the set with and elements. And then after second one, total number of reflexive and the symmetric relations also we will see, we'll calculate. And at last, and we can solve the questions, and that solve means we can discuss about the why you cannot find the number of transitive relations. So let me start first with the first slide. First we have to understand what is reflexive uh, relation. So let's see here. Okay, so here is a slide of reflexive relations. So a set is said to be reflexive if it contains the identical elements, same elements of itself. So this is so let's go through this one example. If RAM is a element set element of set, if another order pair is also the order pair is RAM, then we can say that this is a reflexive relations. You can say there is another example. If there is a let's say Rita is there, then order pair Rita comma Rita, then we can say that this is a reflexive relation. So in the order pair, the first one is the second one is the identical of first pair. So this is how we understood the reflexive pair. A relation R on a set is reflexive if for every element a in a comma a belongs to the R. So we can see the example here. A is a one set 1 comma 2 comma 3. Its relation is 1 comma 1 2 comma 2 3 comma 3 1 comma 2 2 comma 1. But R is reflexive because 1 comma 1 is reflexive, 2 comma 2 is reflexive, and 3 comma 3 is reflexive because it the second element is the identical of the first elements. So this is all about your reflexive. Hope you are getting this one. So let's move on to the next slide. That is your symmetric relation. So symmetric, before going to the definitions, let's start with the examples. For example, if there is a, let's say 1 comma 2. So this is an example. If it is a contained in one relations 1 comma 2 in a relation, if another element any other order pair 2 comma 1 is also present in the same relation, then we can say that it is a symmetric relation. Another example, let's say real life example, there is a Ram comma Sita. So this is a one relation. So if there is another relation is also there, for example Sita comma Ram, so this we called a symmetric. So a comma b is present in the one set, then another order pair like Sita comma Ram is another pair. So in this way we understood what is symmetric. So let's go through the definition. A set or relation R on a set A is symmetric if for every A comma B belongs to R, B comma A should also belongs to the R. So example, let's A is 1 comma 2 comma 3. Its relation is 1 comma 2 2 comma 1 2 comma 3 3 comma 2. So it's symmetric because A comma B in R the pair B comma A also in, you can see in this example 1 comma 2 is also here and 2 comma 1 is also here. So these two are symmetric. Another one is your 2 comma 3 and 3 comma 2 is also here. So we can say this is a symmetric relation. So hope you understand, you are getting this symmetric relations. So move on to the next slide. So that is about the transitive relation. So let's first start with the basic example, general example, daily life example. If there is a, let's say milk and sugar is there, for example. Another set, there is a, let's say sugar 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 and tea. So let's see, and if another set, then after, if there is a tea, or let's say milk comma tea. So this we can say that this simple, this is a transitive relations. So milk comma sugar is there, another set order paid is sugar comma tea, and last one is your milk comma tea. So generally I have given the one examples to make you understand this thing. So this is called transitive relations. Sugar and tea is a transitive, whereas the milk and the tea is the last one. So let's understand from this definition. And a relation R on a set is a transitive if for all elements A, comma B and C in A, if A, comma B belongs to R and B, comma also C belongs to R, then A, comma C belongs to R. So let's go through with the example. A is 1 2 3, is relation is 1 comma 2 2 comma 3 and 1 comma 3. So 1 comma 2 belongs to R, and 2 comma 3 also belongs to R, and 1 comma 3 belongs to R. So therefore R is a transitive relations. uh, so in this way you can understood, and this up to two elements, it is very easy to determine the transitive relations. But if you take the three or the four elements in a set, it will be very difficult us to find out the transitive relation, because we have to check every relations order pair whether it is transitive or not. So at end I have written here note, not all relations are transitive. For examples 1 comma 2 2 comma 3. So 1 comma 2 2 comma 3, and then this 1 comma 2 belongs to R, 2 comma 3 belongs to R relations, but 1 comma 3 does not belongs to R. So it means that this is not a transitive relations. Hope you are getting this from the uh, example I have mentioned above. So simple like that. If father and mother is a one set, if the mother and the daughter is a one set, at last father and mothers is another set. So in this way also you can uh, understand. Just I will write here, if there is a um, mother and father is a one set, then after another relation is father and son, then after you can understand that there is a relation between mother and son also. So this is called father and son. We can take it as a transitive relations. So at last we can write that mother and son also have a relations. So this is the general examples I'm keeping here. So now let's move on to the next topic, that is your counting number of relations. So how to count the number of relations here. So relations, the formula that I have mentioned here, relation we can count here 2n square. There is a formula reflexive 2n square minus n, and the symmetric 2 power n square plus n by 2. So if you put the values, this is the calculation I have given here. If you put 1, you will get the 2 relations. If you put 2, you will get the 16 relation. If you put 3, you will get the 3 relation. This I have calculated and I have keep it here. Next one is your for transitive and equivalence. There is no general formula for this one. So let's you can pause the video and you can see this. Let's now move on to the next topic. The topic is number of reflexive and the symmetric relations. Let me show you through the one example. Okay, let's see here. You can see here there's a uh, a set is we have taken 1 2 3, and it's all a into a universal relation is mentioned here. So these order pairs are classified into two categories. One is your diagonal order pair, which is n number, and another one is your non-diagonal pair. So there is a total, we can say that total number of pairs we can form n square, where among them total diagonal is n. And if you have to calculate non-diagonal pair, if you subtract total from total diagonal elements, you will get the number of non-diagonal pair. So let's move on to the next slide. how many reflection and the symmetric relation can be possible on a given set. So here is a one way to find out the how many reflexive and the symmetric relation can be possible on a given set. So if you multiply number of ways of selecting a diagonal order pair to the number of ways of selecting non-diagonal pair, you will get the you will get the formula to calculate the how many reflexive and the symmetric relation can be possible on a given set. And finally we are getting this formula, that is the 2 power n square minus n by 2. So this is the way to find out the reflexive, how many numbers reflexive and the symmetric relation can be possible. So let's this let me okay, so here this is the way. So if you put a value n, you will get the one answer, how many possibles. So let's put here n equals to 1. So let's quickly find out. So if n square means sorry, 1 is square, let's put here 1 square minus 1 divided by 2. So 1 square, you know already, 1 square is 1, minus 1 and then after divided by 2. So here you can get j 2 power 0, and 2 power 0 is your 1. So if there is a single element is there, so you can found how many 1 reflexive and the symmetric relations. So if there is a number of elements is 2, you can calculate yourself also and find it how many reflection and the symmetric relation can be possible. So move on to the next slide. So this is about the why counting transitive relation is difficult. So in this topic, means in this slide, we are going to talk about, because transitive BT means a relation R on a set is transitive if for every A comma B belongs to R, B comma C also be, relation should be belongs to R, where and then after A comma C should be belongs to the R. Challenges is that unlike the reflexivity and symmetry, transitivity is not easily characterized by a simple pattern, as I have been, mentioned in the previous slide also. It involves the chain dependence among the elements, making it difficult to count directly. So it is almost not impossible. It is difficult to find out the uh, find out the for the if number of n value will be increased, then it will be difficult to find out. For example, they have mentioned that if there is a one element, you can find out transitivity is 1. If there is a two element, that is gradually increases. Okay, so for number of elements increases, and then after it you have to find out like by checking all the possible combinations. And it's not easy, because there is the in a relation there is a n square relation is there. Okay, so like for example, if there is a if you n value is there, so there will be the 16 different relation you will get order pair. And to check it, it will be quite lengthy process also. Hope you are getting this. So this is all about uh, today's videos. Hope you understand the things. If you are not understanding, please let me know in the comment below. So this is all about today classes. Thank you and have a good day.